Hi guys, today we're going to learn about different types of formulas. There are two kinds. There are empirical and molecular formulas. So your job is to figure out what's the difference between them. So an empirical formula is a reduced ratio of the atoms. So basically it means that you simplified the formula. If I say the molecular formula, then that's the actual number of the atoms that are there, and you don't reduce it and you just go on with it. So let's do some examples of what that looks like. If you look at this table, they give you the molecular formula, and so you have to figure out, can you reduce it and make it empirical? So take the subscripts, got 2 and 6, and I like to write it like you'd see it in math class, 2 over 6. That can be reduced to 1 over 3. So that means that I can rewrite this formula where the 2 becomes a 1 and the 6 becomes a 3. So the empirical or reduced formula is NO3. If I look at the next one, when there's nothing written, there's a 1 there. So 1 over 5 is what I have. That can't be reduced anymore, so it's already an empirical formula. The next one is butane. It's C4H10. So I'm going to take the 4 and the 10. Let's see if we can reduce them. Like that. So if you think about, both of those numbers can be divided by 2. So that becomes a 2 over 5. So when I write the empirical formula, it will become C2H5. The 2 went in place of the 4, and the 5 went in place of the 10. If I look at the next one, I have a 2, a 5, and then there's a 1 and a 1. So anytime you have a 1 in there, you can't reduce it anymore. So that means that this formula is already empirical, and we'll leave it exactly the same. Last one, I've got 4 and 6, so let's do that like we would in math class. That does simplify, and it becomes 2 over 3. So when I rewrite the empirical formula, it'll become C2H3. So we just went from molecular to empirical formulas. We took the molecular formulas and simplified them if we could. But now what we're going to figure out how to do is take the empirical formula and go backwards and unreduce it and unsimplify it and make it molecular. Here's how you're going to do that. If you look at the first question, it's written there, we're going to walk through that one together. You're going to use this formula. You're going to do the mm over em, so the molar mass over the empirical mass. So let's see what we have in the question. There's a number. So that number that you're given, it says, is the molar mass. So that number can go on the top. They don't give me the empirical mass. They give me the empirical formula. But we know it's CH, so we can calculate the mass of C and H. So grab your periodic table. The mass of carbon is 12. Plus the mass of hydrogen, which is 1. So this becomes that. So throw that into your calculator. And so you're going to want to make a note right here. The goal of this is you have to get a whole number. And so if it gives you a decimal, then just round it to what the closest whole number is. So my calculator says 6.00923. That's really, really close to 6. So that's the first step, is to get that whole number. Now what you're going to do is you're going to take that and you're going to multiply the subscripts by the answer. So the original formula was CH. Remember, if there's nothing written, it means that there are 1s next to each number. I'm going to take those 1s and I'm going to multiply them by the 6 that I got from the first step. That means that the molecular, the unreduced formula, was C6H6. So what I want you to do is try number 2 if you want. If you're not comfortable, then I'm going to walk through it right now and let's see what we get. Okay, so we know our formula for this. It wants the molecular formula. That means I'm going to do my formula of mm over em. If I look in the question, they gave me that number, and that is the molar mass, so that goes on top. They don't give me the empirical mass, they give me the empirical formula. So we're going to calculate what that weighs. So I've got 4 carbons, they each weigh 12, plus 9 hydrogens weigh 1 apiece. This number and this number came from the periodic table, if you're not sure where I got that from. Okay, so now let's figure out what that is. It's 114 on the top, and let's put this into our calculators and find the empirical mass. I get 57. Now do this division. Remember, your goal is to get a whole number. So I have 2.0040, whole number, that will be 2. Okay? Now we're going to do the next step of go back to the original formula, C4H9, and multiply by the 2 that you found. So times 2 here, times 2 here. The unreduced molecular formula will be C8H18. Alright, that's all there is to it. So right now what I want you to do is try the questions on the bottom. I'm going to scroll through the answers, and then if you need an explanation, I will go through each one so you can pause, rewind, fast forward, and get any help that you need right from this video. Alright, so answers are over here in bold. So let's go through. Okay, if you need help on any of these, I will do out all of the questions so you can jump ahead to whatever you need help with. In number 1, it asks me for the empirical formula. Empirical means I want the reduced version. So if I look at what I'm given, I have a 5 and a 10. That can be simplified to 1 over 2. That means I can rewrite the original formula of C1H2. Number 2 is very similar. I'm looking for the empirical formula. That means I want the reduced version. So if I look at what I'm given, there's a 2 there and there's a 1 there. As soon as you see a 1, it's already done. So you can't reduce it anymore, and you have to leave it exactly the same as it already was. It's already reduced. In question number 3, I'm looking for the molecular formula. If you're looking for molecular formula, mm over em. So let's find that. Here's the number that they give me. That number is the molar mass number, so that goes on top. On the bottom, they give me the empirical formula, which is this. So we're going to find the mass of that. 1 carbon weighs 12. There are 2 hydrogens. They weigh 1 each. This number and this number came from the periodic table. So now let's put that into our calculators. Find the mass down here, which is 14. So here my calculator says 4.01. Remember, the goal here is you have to get a whole number. So you're going to round it, which becomes 4. Then go back to your original formula, CH2. Nothing here means that it's a 1. And multiply both of those things by 4. That becomes C4H8. In question number 4, we're looking for the molecular formula. Whenever you need molecular, then you do mm over em. So if we look at what we're given, the question has this number right here, and that number is the molar mass number, so that number goes on top. On the bottom, the empirical formula is HO, so we need to figure out what that weighs. H has a mass of 1. Add it to oxygen, which is 16. So that becomes 17. You can put that in your calculator. So we get this big long decimal, make it a whole number, and we get 2. Now we'll go back to our original formula of HO. There are really 1's hidden in there for subscripts, and we're going to multiply both of those by the 2 that we calculated. Then it becomes H2O2. Alright, a couple more. In question number 5, I want the molecular formula. That means I have to do mm over em. They give me this number right here. That number is the molar mass, so that number goes on top. On the bottom, the empirical formula is this, C2H8N. So we need to find the mass of that thing. So grab your periodic table. There are 2 carbons, and they weigh 12 each. Plus, there are 8 hydrogens, and they weigh 1 apiece. Plus, there's 1 nitrogen, and that weighs 14 apiece. So these numbers in the parentheses came from masses on the periodic table. Okay? Now let's see if we can calculate this on the bottom, what that equals. So my calculator says 46. So when I divide those two numbers, I get 1.001956. Make that into a whole number and you get 1. That means your original formula, multiply each of the subscripts that is there by 1, which essentially means it stays the same. It already is correct. In number 6, we are looking for the molecular formula. Molecular formula means you do mm over em. The molar mass that they give me is here. That tells me it's the molar mass number, so I know I'll put it on top. Divide by. They don't give me the empirical mass, so we use the empirical formula instead. The empirical formula that we have is CH. So the mass of that carbon weighs 12, hydrogen weighs 1, so we can add that up. Then you can put that into your calculator. So this says 8.0123, that becomes the whole number of 8. Go back to your original formula of CH. Remember there are secret 1's in there, even though they aren't written, and we're going to multiply by that 8 that we found. When both of those get multiplied 8, it becomes C8H8. Alright, let's check out number 7. Looking for molecular formula means mm over em. Okay? The molar mass number that they give me is here, so I know that that will go on the top. Divided by the empirical formula here is what we'll use to calculate the mass on the bottom. There's 1 carbon and it weighs 12, plus there are 2 hydrogens and they weigh 1 each. So put this into your calculator. Divide here, this is 14. Now let's do that division. This says 8.01714, that becomes a whole number of 8. Go back to your original formula of CH2. If there's nothing written there, there's a secret 1 in there, and multiply both of the pieces by that 8 that you found. That becomes C8H16. Alright, last one. If you need a little bit of help, I'm looking for the molecular formula. So that gives me mm over em. The molar mass is given to me right there, and it says molar mass, so I know that number goes on the top. The empirical formula that they give me is this. So we've got to figure out what that weighs. So there's 2 carbons in there. If I look on the periodic table, they weigh 12 apiece. Plus, there's one oxygen that weighs 16. Plus 4 hydrogens that weigh 1 apiece. So now let's put all of this on the bottom into our calculators and get a mass there for the empirical formula. So my calculator says 44. When I divide, it comes out to a perfect 2. So go back to the original C2, there's a 1 there because nothing's written. 4. Multiply all the pieces by that 2. When you do that, it turns into that answer. All right, let me know if you have any questions.